In today's session, we are going to discuss another important topic, that is differentiation of primary, secondary, and tertiary alcohol using Victor Mayer method. Okay. In board examination, question is asked like this: differentiate primary, secondary, and tertiary alcohol using Victor Mayer method with equation. Okay, is it clear up to here? So let us start discussion on this topic. So Victor Mayer method, Victor Mayer method is used to distinguish primary, secondary, and tertiary alcohol. Okay, and the method is depend on color observed. Okay, alcohol method, why we are using Victor Mayer method to distinguish primary, secondary, and tertiary alcohol is mainly depends on color observed. This method was developed by German chemist Victor Mayer. Okay. Now let us discuss what happened when alcohol is treated with Victor Mayer reagent. Victor Mayer reagent is nothing but Victor Mayer reagent. It is red phosphorus, iodine, and silver nitrite, nitrous acid, and base Na4. Okay. This test is carried out by the following step. How we can perform this test? So first of all, alcohol is treated with iodine in the presence of red phosphorus. to give iodoalkane. Then after iodoalkane is allowed to react with alcoholic silver nitride AgNO2 solution to obtain nitroalkane RNO2. Okay. Now in the next step, the nitroalkane obtained is treated with nitrous acid HNO2 and the solution which resulted is made alkaline using either potassium hydroxide solution or sodium hydroxide solution. Okay, whatever available in the laboratory. Then color is obtained. What type of color is obtained? Let us see in the next page. Observation. Primary alcohol. Primary alcohol gives blood red color, and this blood red color is due to the formation of sodium salt of nitrolic acid. And this sodium salt of nitrolic acid is red in color itself. Okay. If the alcohol given is secondary, then it will give blue color when it is treated with Victor Mayer reagent, and blue color is formed due to the formation of pseudonitrile, which alkaline solution is blue in color. On the other hand, if a tertiary solution is given, then there is no color change because due to the lack of acidic hydrogen, nitroalkane does not react with nitrous acid and sodium hydroxide solution. Okay, so in this way we can differentiate primary, secondary and tertiary alcohol. Okay, if a color obtained is red color, it will be primary. Color is blue color, it will be secondary. And if there is no color obtained, then it will be tertiary alcohol. Clear? Now the reaction is shown here. This is primary alcohol, secondary alcohol and tertiary alcohol. We are having alcohol, and alcohol is treated with red phosphorus and iodine, giving iodoalkane. This iodoalkane is going to treat with silver nitride solution and giving nitroalkane, and this nitroalkane is treated with nitrous acid and gives us nitrolic acid, and making alkaline this nitrolic acid, it gives sodium salt of nitrolic acid, which is red in color. In the same way, nitroalkane react with nitrous acid and gives pseudonitrile, and this pseudonitrile is blue in color. But in this case, that is tertiary, after obtaining nitroalkane, there is no acidic hydrogen. You can see here 3R group is attached with this carbon atom. It means there is no acidic hydrogen. And if there is no acidic hydrogen, nitrous acid does not react with nitroalkane, and if there is no reaction, it does not give any color. It means it is colorless. So in this way we can differentiate primary, secondary and tertiary alcohol. Now let us see how the mechanism of reaction takes place. Mechanism of the reaction. So mechanism of this reaction is proceeds via SN2 mechanism. In the first step, look at here carefully, phosphorus triiodide that we obtained from the reaction between red phosphorus and iodine is electron deficient species because it has a vacant orbital and act as Lewis acid. It accepts lone pair of electron from the oxygen atom of alcohol molecule, and at the same time the iodine attract this shared pair of electron towards itself and gives iodide ion, and this iodide ion is nucleophile. So this nucleophile attack this nucleophilic center and giving us iodoalkane. This reaction proceeds 3 times and gives us 3 molecules of iodoalkane and phosphorus acid. Now in the second step, iodoalkane that we obtained in the first step react with silver nitride. Here nitrogen attack the carbon atom because nitrogen is less electronegative than oxygen. It means its electron is free to attack, and carbon nitrogen bond is stronger than the carbon oxygen. Okay, and gives us here nitroalkane. Again, this nitroalkane is treated with nitrous acid. This lone pair of electron of oxygen atom grab this hydrogen, and the shared pair of electron between carbon and hydrogen move towards carbon and gives nucleophile. Now this protonated nitrous acid gives us nitrosonium ion, which is electrophile, and this electrophile attack nucleophilic carbon center and ultimately it gives pseudonitrile, and this pseudonitrile is blue in color. If it is tertiary alcohol, reaction stops this stage due to the lack of acidic hydrogen, because if it is 3-degree alcohol, this hydrogen is replaced by R group. Now in the next step, pseudonitrile is treated with sodium hydroxide and gives us sodium salt of nitrolic acid, and this nitrolic acid is red in color. Here, due to the presence of this alpha hydrogen, acidic hydrogen, tautomerism takes place, and due to tautomerism it produces nitrolic acid. This is nitrolic acid, And when this nitric acid is made alkaline using sodium hydroxide or potassium hydroxide, it gives its salt, corresponding salt, and this salt is red in color. Okay, so this is the mechanism of the reaction. Okay, is it clear up to here? You can take screenshot for your further use. Page number 1 for introduction. Page number 3, how the reaction is carried out, and this reaction procedure, this is chemical equation, and finally this is observation and mechanism of the reaction. Okay, thank you. If you like this video, please like and